Today we're going to learn how to factor binomials. Factoring is basically just undistributing. Okay, you all know what it means to distribute. Today we're just going to undistribute. Now this is how it works. The first thing you need to do is figure out what you're going to factor out. Okay, figure out the greatest common factors of these two terms. So we have the term 3x squared and we have the term 12x. What are the prime factors of 3x squared? 3x and x will make a 3x squared, correct? What will make a 12 when you break it down into prime numbers? 6 is not prime. 4 is not prime. 3. 4 is not prime. 2. And then what else? And another 2. Those are prime numbers that will multiply to 12, correct? And then it has 1x, so we put 1x. Now I see that they both have a 3 and they both have an x. That means 3x is their GCF, and that's what we're going to factor out. Now in the top row, we didn't, just pay attention. We didn't circle an x, so it goes back. You bring down the minus. In the bottom row, we didn't circle a 2 and a 2, and these are being multiplied, so that's a 4. And then you're done. It's factored. Now, the way you can quickly check to make sure you have done it right is distribute it back out in your head. 3x times x is 3x squared. 3x times negative 4 is negative 12x. So that's how you know you have factored it correctly. Okay, number 3. We have two different terms. We have a v squared and we have a 7v. How do you get a v squared with just primes? V times v. How do you get a 7v? 7 times v. You don't have to write the 1. Okay, so now what's the only thing those two terms have in common? They both have at least one v. So that's all we're going to be able to pull out because that's all they have in common. Now on the top row, v was not circled. On the bottom row, 7 was not circled, and plus just comes down. And then that's your answer. Now let's check the answer. What's v times v? And what's v times 7? So it's right. See how it's just undistributing basically? Alright, number 5. We have 6m cubed and we have 12m squared. What are the prime factors of 6? 3 and 2. And then m cubed, wouldn't that be m times m times m? Okay, what are the prime factors of 12? 6 is not prime. 3, 2, and 2. And see how if you did, like say you did 3 times 4. Well, if you did 3 times 4, you wouldn't have this other 2 to circle. That's why you have to break it down into primes so that we see that we have 2's to circle as well. And then that one has m squared, so 2 m's. So now I see that they both have at least a 3, they both have a 2, and they both have 2 m's. So what does the circle things multiply up to? 6m squared. And then on the top row we didn't circle an m, on the bottom row we didn't circle a 2, and then bring down the minus. And then you can quickly check it by just distributing it in your head. What's 6m squared times m? Right. What's 6m squared times negative 2? Negative 12m squared. Yeah, 3 times 2 is 6, m times m is m squared. So 6m squared comes out. Okay, number 7. We have an a squared and we have an 8a. So what are the prime factors of an a squared? Just a times a. Okay, what are the prime factors of 8a? Well, just 3 2's. And then an A, right? However, on this one, is it really going to benefit us to write out all 3 2's? Is there any number to circle up there? So when you get to a problem like this and you say, oh, well, there's no numbers up there, don't even worry about breaking down the 8. Just leave it A and then A. Because there weren't any numbers up there to circle with numbers. So you can break it down if you want, but it's not going to matter. Does that make sense to everybody? Okay, so now what's the only thing they have in common? A. A. Okay, you got to pay attention to know what we're doing. So you pull out an A, and then A was not circled right there, and 8 was not circled, and the minus comes down, and then it's easy to check. A times A is A squared. A times negative 8 is negative 8A, so that's right. Okay, number 9. We have k to the 4th, and we have 10k to the 3rd. So what are the prime factors of k to the 4th? Right, 4 k's. What about 10? 5 times 5 is 10? Okay, but is it really going to matter if we break down the 10 into a 5 and a 2? Right, there's no numbers up top. So you can just not worry about breaking down a number on bottom when there's no numbers in the top. And then on the bottom you have k, k, k. Okay? So now we need to circle. What all do they have in common? 3 k's. So what gets factored out? K cubed, right. Because k times k times k is k cubed. Now, what gets left inside? Very good. And then you can quickly check it. K cubed times k is k to the 4th. K cubed times 10 is 10k cubed, so it's right. Okay, I'm going to give you just a couple of minutes to go to the right side and try 2 through 10 even. So that's only 5 problems. Again. Okay, I'm going to be flipping back to page 5, but you don't have to. You just need to watch. Okay. Back when we did page 5, and we did number 7 and 9, we discovered something, okay? So let's go back over what we discovered. When we distributed these two binomials together, 3 times 3 made 9, 3 times negative 7x made a negative 21x, 7x times 3 made a positive 21x, and 7x times negative 7x is negative 49x squared. Then, when we went to combine like terms, negative 21x plus 21x cancels out. And we were left with 9 minus 49x, which we then quickly rewrote into standard form, meaning that the exponents go from highest to lowest. So this would come first, and this would come last. Okay, so now let's look at this next one. 1 times 1 is 1. 1 times negative 8x is negative 8x. Positive 8x times 1 is positive 8x. Leave him alone. He's trying to pay attention. And 8x times negative 8x is negative 64x squared. Okay? You'll notice when you go to combine like terms, these cancel each other out because negative 8x plus 8x is 0. So it cancels out, leaving 1 minus 64x squared, which in standard form would be negative 64x squared plus 1. So see how when the binomials that you're multiplying are almost identical except for the signs, the middle cancels out, and it happens every time. These are almost identical except for their signs, and the middle canceled out. All you're left with is an x squared term and a constant. You don't have an x to the first term anymore. Okay? That's because it's a difference of 2 squares today. So let's look at what I'm talking about. 9x squared minus 9. The reason this is called a difference of 2 squares is difference for the obvious reason that they're subtracting them, and 2 squares because each of these are perfect squares. What do I mean when I say a perfect square? Why is 9 a perfect square? Because 3 times itself will produce 9. Why is x squared a perfect square? Because x times x will make x squared. Okay, so does everybody understand what a perfect square is? So this is a perfect square, and this is a perfect square. So anytime you see a binomial and it's a difference of two squares, meaning two perfect squares are being subtracted, you always factor it like this into two binomials. They're going to be identical except for their signs. So what times what will produce a 9x squared? A 9x squared? Well, if you take a 3x and multiply it by another 3x, won't that make a 9x squared? You said 3. Okay, and then how can you get a 1? 1 times 1. And see how they almost match except for their signs, and that's when the middle's gone? You just had an x squared term and a constant term? Yes? Hold on, Marty's first. Go. Yes. But the negative just lets you know this is a difference of two squares, so you have a special way of doing that. You're just looking for what will make a 9x squared and what will make a 1, and then you just do opposite signs. Well, yeah, but I mean, because think about it. To get this to end up being minus 1, don't you have to have a positive 1 and a negative 1 multiplied? Okay, no, that's why I didn't teach that first. This is different. Okay, so look at number 13. Again, we're dealing with a difference of two squares. Difference, because minus means difference. Two squares, because isn't 4n squared a perfect square? Why is 4n squared a perfect square? Well, to get 4n squared, wouldn't you have to do 2n times itself? And why is 1 a perfect square? 1 times itself. So when you factor a difference of two squares, you just look for what will make that, and that's 2n times 2n. And then to get a negative 1, a positive 1, and a negative 1. That's all you do. Anytime you look at something and you immediately recognize, oh, that's a difference of two squares, you know your answers are going to be almost the same except for opposite signs. Well, you just have to look at it. Like, look up at number 10. Is 5 a perfect square? No. So you would know this is not that kind of problem. This is the kind of problem where we have to do it like we were doing it earlier. But when we look at problems down here, we see that every single number is a perfect square down there. And so you do it this way. So just try, I'll leave this up here so you can reference it. Try 12 and 14 by yourself. Okay, so right away when I look at number 12, I see a subtraction sign, which lets me know it's a difference. And then is 16x squared a perfect square? Is 1 a perfect square? So this is a difference of two squares. And anytime you're asked to factor a difference of two squares, you know your answers are going to be almost the same thing. Okay, they're almost going to match, except for the what? The signs are going to be opposite. So what can I multiply by itself to produce a 16x squared? 4x and 4x. And then what do I multiply by itself to produce a 1? 1 times 1. So that's your answer. Okay, so for number 14, it's a difference. Is it two perfect squares? Yes. Yeah, a and a squared is. Isn't a squared is a times itself? And is it 25 just 5 times itself? So both of those are perfect squares. This is a difference of two squares, but the only thing that has to be different is the signs for two reasons. To make a negative 25, you have to have a positive 5 and a negative 5. And you don't have to write this, just watch. Okay, everybody just watch. A times a is a squared. A times negative 5 is negative 5a. Positive 5 times a is positive 5a. And positive 5 times negative 5 is negative 25. So look, don't the negative 5a and the 5a cancel each other out, leaving just a squared minus 25, which is what we started with? That's why the signs have to be opposite so that the middle will cancel out. Okay, now turn to page 9. Okay, let's go down to problem number 21. It's a little bit different because you're dealing with two variables, but it's not any harder, okay? Is this a difference? Is it a difference of two squares? Yes. 25x squared is a perfect square because you can multiply what by itself to get it? X times 5x will produce 25x squared, correct? And then what multiplied by itself will give you a 4y squared? 2y and 2y. But to get the middle to cancel out, because the middle is no longer there, and to make it a negative 4, you need opposite signs. Yes? Well, not always. There are some that do. You just have to pay attention and notice if both terms are perfect squares. Then you have to do it the other way that we learned at the beginning of class. Okay, so for this one, is this a difference of two squares? Yes, because to get u squared, don't you just have to do u times itself? And to get 25v squared, you can do 5v times itself. And then to get it the middle to cancel out and to make this a negative 25, you just have to have opposite signs. Okay, try 25 quickly. Okay, is 25 a difference of two squares? Yes, difference for sure because there's a minus sign. And then both of these terms are perfect squares. Perfect square meaning you can multiply something by itself to produce it. What can I multiply by itself to produce 25x squared? 5x and 5x. And then what can I multiply by itself to produce y squared? Y times itself. But then to make it negative, you need one positive, one negative. Okay, your job is to finish page 9, and then when you're done with that, to continue working on pages 10 through 13. Because tomorrow is when we'll have to start using that, multiplying to find a number, adding to find a number. Okay? So, yeah, page 9 is your homework basically. So you'll get it done in class, and then you need to work on 10 through 13.